This is a metal cutting lathe. All lathes have in common the fact that they have a spindle that's turning the work and a stationary tool that's cutting it. This one is made for, this can cut wood, but it's made for cutting metal, which takes a lot more force, so it's much more robust. The headstock's here. It contains the transmission and the drive system for the spindle. That's what turns the work. Lets you pick different speeds depending on the size of the work. The tailstock is lined up with that and rides along ways to stay lined up, and can be locked in position and advanced into the work if you have a drill chuck. You can put a drill chuck in it to drill holes. You can put a live center in it to support the work. In between the two, the carriage is what moves left and right along the ways, another set of ways. Keeps it lined up. So it moves towards and away from the headstock. The cross slide moves in and out to change the diameter that you're cutting. And this is called the compound rest, which is able to be set at different angles if you need to cut a specific angle. So let's put a piece of material in the chuck and demonstrate what the lathe can do. This lathe is equipped with a quick change tool post. There's the cutting tool. That's the holder. It slides on a really accurate dovetail onto the quick change post and locks down with that lever. I'm going to take it off to get that sharp edge away from the chuck, and I'm going to put a piece of material into the jaws of the chuck. This is a 3-jaw chuck. So these, when I tighten this, the 3 jaws come in equidistantly to keep the work centered. And this chuck key belongs in only 2 places, either in your hand or back over here. If you leave it in the chuck and turn the lathe on, that is a lethal projectile. So don't ever let go of it, just put it back where it belongs. Okay, so now we can put the tool back in, making sure that the tool post is free of chips and the tool holder is free of chips, and locking it in place. And if you'll come around this side, you can see what's going on here. So I have left-right control of the tool here and in and out control of the tool here. Let's pick a speed. I'm putting it in high range, 755 RPM. In order to start it up, I'm turning this knob, not pulling it out. I'm just turning it. It'll pop out by itself. I get 1 green light here. Push that to get 2 green lights, and now I can start and stop the lathe with this handle right here. So to the right, neutral is locked in position. To the right and down. Makes the lathe running forward. Forward is when the spindle is turning towards you at the top. Okay. The cutting tool is like this. The work is going to be turning, and the cutting tool is going to be taking a chip off of it. So for a demonstration cut, so now the end of that part is perfectly square and flat. And when I do that, I can zero out. The Z length on the lathe is in and out towards the spindle, so my left and right is the Z or long dimension. My X is the diameter dimension. So I've just faced this off at 0. And reset the Z there. That zeroes it. This Z is for preloading numbers in there. We'll get to that later. Okay? So I know that this material is 3/4 of an inch in diameter, so if I wanted to preset the X dimension, I can come in there until it's just touching the work. Let's stop it. If I zero the X, it doesn't tell me anything, it just tells me that I've zeroed it out. That could be a reference. But if I want to enter the dimension of it, I can type X 0.75 load, and now I have a starting point for reading my diameter. This X dimension is set up to read on the diameter. It doesn't read how far the tool moves, it reads how much you're changing the diameter, because when you're making a cut on the lathe, it's making a cut all the way around the part. So let's make a cut down to, say, 650. Always want to make sure that the lathe is completely stopped before you reach anywhere near there. Now, if we wanted to get a really accurate dimension here, we haven't moved the tool since we cut this. We can measure this and reassign a number here that was precisely right. So this is capable of doing really accurate work. If we wanted to drill a hole in the end of this part, you take that tool out. We could start with a center drill, which is a little stubby drill made for starting holes. So now I've got an accurate start for that hole. I wanted to drill it with something bigger. Make sure that this handle is a tenth of an inch or 100 thousandths. So you can drill to an exact depth. Up to now we've been stopping the lathe just by lifting the handle until it pops back into neutral. If you lift the handle all the way up instead of letting it drop back into neutral, it'll keep running. So make sure that you always stop in neutral. In an emergency, you can step on the foot brake and it will immediately stop the lathe. At which point it won't start up again until you A, put it in neutral, and B, re-energize it.